In this lesson, you will learn how to find a formula for the nth term of a geometric sequence and to find specified terms of geometric sequences. Now remember, geometric sequence is something where the pattern is where you multiply or divide by something to get to the next term. So for example, here we see 2, 6, 18, 54, etc. And the pattern is you're multiplying by 3 every time. So this would be considered a geometric sequence. And now the question is, how do we find the 12th term? Well, yes, we could keep multiplying over and over again until we reach the 12th term, but the objective is to get to a formula so that we don't have to keep multiplying over and over again. So the pattern, like we said, is multiplying by 3 every time. And the question is, if we're starting with 2, how many times do we have to multiply by 3 to get to the 12th term? Well, 2 is already term 1, so to get to the next term, term 2, that's when we start multiplying by 3. So we're actually multiplying by 3 11 times to get to the 12th term. So there's 11 common ratios. We multiply by 3 11 times. So what I do is I take 2 times 3 times 3 times 3, etc. Do that 11 times, which would be the same thing as 3 to the 11th power. And then 3 to the 11th power would be 177,147. Then multiply by 2 to get 354,294. Now in general, what we have just done is to find a given term. So in this case, term 12. But to find a given term, we started with the first term, so 2 in this case, then multiplied by the common ratio a certain number of times. How many times do we multiply? Well, if we were trying to find the 12th term, we multiplied by 1 less than that, or 11. And so what I do is I take the term number, whatever it is, 12 or whatever, and subtract 1, and that is my exponent. That's the number of times that I'm multiplying by the common ratio. So my equation that I can use to solve for any geometric sequence is t sub n equals t1 times r to the n minus 1 power. Now looking at the same sequence, let's say we're trying to find the nth term. So instead of the 12th term, we're trying to find some nth term. And our objective is to write an equation so that I don't have to always plug in the common ratio every time, where I can just simply plug in the term number that I'm trying to find. So what I can do is use the same equation and just plug in everything except for n. So t1 is the first term, which is 2. That's your first term. Common ratio in this case is you're multiplying by 3, so put a 3 in for r. So to find a given term, I take 2 times, and then it's going to be 3 to the n minus 1 power. And that's going to be my equation that I can use, where all I need to do now is, if you're trying to find a given term, I can just plug in the term number to solve. And I'm not concerned anymore with term 1 or the common ratio. So for example, say we're trying to find the 100th term. So the 100th term, all you do is you plug in a 100 in for n. So we have 2 times 3 to the 100 minus 1 power, which would be 99. And whatever that is equal to would be your solution. So in this case, we're not really saving too much time because finding t1 and r are pretty quick. But it does save you a little time. And if you're asked to find the equation for the nth term, you want to find something like this, where Tn equals something, and actually, sorry, right here is what we're looking for, where Tn equals something, and then just leave the n in there. And that would be my solution. Now the question is, what if you're trying to find the 6th term if given the sequence 3, negative 12, 48, negative 192? So yes, we could multiply just 2 more times to get to the correct solution, but our objective is to learn how to use the formula. And I'm using small term numbers because if I use larger term numbers, the numbers that we're going to be using would be very, very large because we're multiplying over and over again. So I'm using a 6th term because we don't want the numbers to become too large on us. But to find the 6th term using the formula, we plug in t1, r, and n to find the given term. So the sixth term means we're trying to find term 6. And so t6 would go right there. t1 is term 1, and term 1 is 3. So plug that in right there. And then r is your common ratio. So what are you multiplying by to get to the next term? Well, you're multiplying by -4. Right? 3 times -4 gives you -12. -12 times -4 gives you a +48, and etc. So r is -4, and then n is a number of terms we're trying to find. We're trying to find the sixth term, so 6 would be your n. So we have 6 minus 1, which would give me a 5 for the exponent. So then I multiply and get -4 to the 5th power, and then times that by 3, and we get -3072. Here's another example where the numbers in the sequence are getting smaller. And we still use the same formula because this is still a geometric sequence. And using the formula, t1 is term 1, which is going to be 1600. R is the common ratio, which is what you're multiplying by to get from term to term. Well, it might not be as obvious to you, but what I can do is I can take -800 divided by 1600, and that's going to give me a -1/2. And I can do that for any set of numbers. -200 divided by 400, I would still get -1/2. So my common ratio is -1/2. And n is the term number that I'm trying to find, which is going to be 12. So I plug everything into the formula, and I get 1600 times -1/2 to the 11th power. -1/2 to the 11th power times 1600 would give me a solution of -0.78125. One last example where the difficulty will increase, because here we are given term 3 as being 10, term 6 is -80, and we're trying to find term 14, but I don't know term 1 or the common ratio. So we're also told that this is geometric, so we know it's going to be the same formula to find our solution. But in order to find the common ratio, I need to use the fact that we are dealing with a geometric sequence, which means I'm multiplying to get from term to term. So if you're looking here at term 3 and term 6, we know to get from term 3 to term 6, I'm multiplying by the common ratio a certain number of times. Well, to get from term 3 to term 4, I multiply by the common ratio 1 time, right? Because term 3 times the common ratio takes me to the next term, term 4. Well, then to get to term 5, I multiply by the common ratio again. To get to term 6, I multiply by the common ratio 3 times. And that's what I want to do. I want to connect term 3 to term 6 to figure out what is this common ratio. Well, I can now plug in term 3 and term 6 as being 10 and -80. So I plug that in. I get 10 times r cubed equals -80. And it's r cubed because r times r times r is r cubed. Solve for r. I can divide both sides by 10. And now I have r cubed equals a -8. And then to get r by itself, I get rid of the cube by taking the cube root of both sides, which leaves me with r equaling -2, because -2 cubed is -8. So now I found the common ratio, and I can plug that in for r, but I still do not know term 1. So to find term 1, I'm going to use the same logic that I just used to find the common ratio, where I know to get from term to term, I need to multiply by a common ratio. So now I'm trying to connect term 1 to find term 1, and connect that with term 3. Well, to get from term 1 to term 2, I multiply by the common ratio, and to get from term 1 to term 3, I multiply by it twice. And in this case, the common ratio we already know now to be -2. So multiply by -2 twice, that'll take me to term 3. So then I can solve this, because -2 times -2 is a +4. Term 3 we know to be 10, and then plug that in, solve for t1 by dividing both sides by 4. So term 1 equals 10 over 4, which is equal to 5/2. So now we just plug everything into the formula. T1 is 5 halves, and then our common ratio is -2, and then n is the number of term we're trying to find, which is 14. So then 14 minus 1 is 13. -2 to the 13th power is -8,192. And then multiply that by 5 halves to give me -20,480. And that concludes our lesson for today. We will see you next time.